1, 1, 4, 1, 2, 1, 5, 2, 2, 3, 2, 4, 4, 1, 3. So let's try to find the cofactor for the row, for the first row and first column, which is 2. The first thing we need to do is close the first row and first column. So the number left that you can see is 2, 1, 5, 2, 3, 2, 4, 1, 3. And then the next step is we also close the first row and first column, which is the number left is 3, 2, 1, 3. So 3 times 3 minus 2, 2 times 1, which is 7, and times with 2. As we know that the first number is plus, minus, and plus, so the next one is minus 1 times 2, 2 times 3 minus 2 times 4, which is equal to negative 2, plus 5 times 2, 2 times 1 minus 3 times 4, which is equal to negative 10, and we get the negative 4. So for the next 1, 2, 1, 3, 1, 4, 2, 1, the process is just the same. So the cofactor we get is negative 34, negative 41, 2 tenths, negative 31, negative 34, negative 2, negative 10, 4, negative 1, negative 27, negative 5, negative 9, negative 14, negative 12, and 5. And the next step we need to do is to do the negative, positive, negative, positive, negative.
Greetings everyone. So today I'll be giving you a brief explanation on how to determine the determinant of the matrices. So, as my friend has explained before, the easiest way to actually determine the determinant is that find the cofactor of the matrices first. So once you have solved for the cofactor of the matrices, you can do a direct and simple working in which you can obtain the determinant. So first of all, looking at the working here in which my friend has explained, we'll be getting the cofactors as shown here, which is negative 31 plus 41 and so on. So right now, to get the determinant of a particular matrix, choose a certain row or either a column. So in my case, I'll be choosing the first row, and it's up to you if you'd like to choose the second row or the second column, anyway. But make sure when you're choosing the particular row, it corresponds to the row you'll be choosing in your cofactor. So now there'll be a comparison done between the original matrices and also the cofactor found based on the original matrices. So now that I'm taking the first row, let me ignore or neglect all the other elements in the original matrix and the cofactor. So the first element of the first row is 2, in which I'll have to multiply it with the first element of the cofactor found. So as you can see, the cofactor has been found by this and this for the first element. So 2 multiplied by negative 34, and then you have to just plus with the second element, multiply with the second cofactor of the matrices, which is 1 times by 41. So you get plus 41. If you're going to do the long way in which you want to see the minus and cofactors, then you'll be, based on your cofactor, you'll get negative 1, and your minor is actually negative 41. But since you have solved for the cofactor itself, you can directly take the negative 34 and plus with the 41, and then proceed and to do the same for the third and fourth element of the first row, in which you multiply the third element of the original matrix with the third element of the cofactor, and then plus the entire row, and you'll get your final answer, which is negative 65, which is equivalent to the determinant. Thank you. Now, to actually determine the inverse of the entire matrices, this will be the formula. 1 over determinant multiplied by adjoint A. So what is adjoint A? Adjoint A is basically C transpose, in which if you refer to the values, this will be your C transpose. Now how do we get the transpose? It's basically we just reverse the rows and columns. For example, referring here, we have A12. Element A12 is 41, right? So when you transpose element A12, it becomes A21, in which if the row is 1 and the column is 2, when you transpose it, the row becomes 2 and the column becomes 1. So do the entire thing for the whole cofactor, which you transpose and you get adjoint A. So as shown before, we have already determined the determinant of the matrices, which is negative 65. So to actually get the inverse of the matrix, all you'll have to do is take the inverse and put it over 1 and multiply it with the cofactor. Transpose. Thank you. So basically, once we've done with everything, now it's the process where we want to decrypt the message. So to decrypt the message for K1, all we have to do is multiply it with the matrices P, which is already given. So in which we will finally get the answer or the code we want for K1, in which we'll be comparing to the list of alphabets given. So M multiplied by K inverse, you will get the answer. Salah tu. Sebab. Okay, so finally, based on this given formula, once we've determined the K inverse, all we'll have to do to find the answer for K1 is by multiplying it with the matrices P, which is given. However, when we multiply P by K inverse, we get this answer. And when we compare this to the list of alphabets, which is our coding sequence given, we cannot get a proper or appropriate meaningful sentence, which means K1 has no answer. Thank you.
Now I'm going to explain on how to get the K2 inverse by using ARO method. Basically, what is ARO method? ARO method is it have a big bracket that have two sides, which is left side and right side. The left side will be your question, and the right side will be your identity. So, ARO method is just you want to swap by changing the question to be its identity. So, to solve the ARO method will be solved by the row and the row. For example, row 2 minus row 1. So we will take the row 2 minus row 1. 5 minus 4 will become to row 1 is equal to row 2 minus row 1. So basically we want to change the row 1 into 1 because we want to change it into the identity, right? So we make it by row 1 is equal to row 2 minus row 1. So 5 minus 4 is equal to 1. And 1 minus 1 is equal to 0, 1 minus 1 is equal to 0, and 2 minus 4 is equal to negative 2. If we subtract the left side, we also have to subtract the right side because it's the same row, right? 2, 1. So 0 minus 1 is equal to negative 1, 1 minus 0 is 1, and 0, 0, 0, and 0 minus 0 is 0. So basically, this operation will continue, and you also can subtract and multiply it, divide it. Okay, so we continue by times, minus, and the answer will be like this, just like I told you. The left side must be identity, and the right side will be your inverse that you want to find out.
Right, so as we know from what Wafi explained, this will be the inverse matrix. So this is the inverse for K2. Alright, to obtain the message, the decryption, we have to use the formula given same as the K1, which is P times inverse of K2. So the P is given by the question, as we know, and we will use the inverse for K2. So how do we obtain? So as we know, we have to times the row 1 with the column 1, row 2 with the column 2, row 3 with the column 3, and row 4 with the column 4. So when we times all and plus, we will get the answer for K2. As we already wanted to translate this to the coding, we can't obtain any message as it is all in a fraction and it is not in a normal type of A, B, C or 1, 2, 3. So the answer for K2 is invalid. Thank you.
The next question, we use the matrix K3, which is given like this. So for K3, I will use the same method as K1, which is adjoint method. So to solve using adjoint method, we must find the determinant first. So for finding the determinant, I got the answer is negative 21. Next, we find the cofactor of each element in the matrix. So after, for example, I will use the first row and first column elements, so I will get 0. Using the same method as above, I will get all these elements which we call the cofactor. But we must transpose it, so I will get this matrix. After we find the cofactor and we transpose it, we will get the inverse for the matrix. So the last step, actually we will describe all this, describe it by multiply it the P matrix with K inverse. Usually, actually the P matrix was given at this question, and we multiply it with the K inverse. So last we will get the answer, the matrix. So according to the table given, we will describe each of the element. So after we describe all this, the matrix, so we got the answer is mathematics magics. That's all. So the answer fulfill the task.